Hello, I'm Alexis Ian A. Dahoran, reporting Industrial Automation and Control. First, I'm going to report control system. A control system is a device to manage, command, direct, or regulate the behavior of other devices. The three components of control system are input devices, control devices, output devices. First, the input devices. The input devices is any device or equipment that is used to provide data or control signals into particular processing system. Next is the control devices. Control devices are devices that, when combined to a proper configuration, can create logic to perform a specific process. And thus is the output devices. The output devices are devices that can be controlled to create a necessary output. One of the examples of the input devices is the push button. The push button are pressed to cause movements. It's either open or close contact. This is the push button, and its symbol is normally open. The next is the toggle switch. The toggle switch is a device having a plurality of terminals and means operated by a lever for making electrical connections between pairs of those terminals. This is the toggle switch, and its symbol is this. Next is the rocker switch. Rocker switch is similar to toggle switch but operated by a rocker. This is the rocker switch. Next is the limit switch. Limit switch is configured to detect when a system element has moved to a certain position. This is the example of limit switch. The next is the examples of control devices. One of the examples is the inductive proximity sensor. The inductive proximity sensor is an electronic proximity sensor which detects metallic objects without touching. It uses electromagnetic field to sense objects. This is the example of inductive proximity sensor. The next one is the capacitive proximity sensor. The capacitive proximity sensor is similar to inductive proximity sensor. The difference of it is it uses electrostatic field in which it can sense metal as well as non-metallic material. This is the example of capacitive proximity sensor. The next one is the photoelectric sensor. The photoelectric sensor is another type of positioning sensing device. The photoelectric sensor uses a modulated light beams that is either broken or reflected by the target. This is the example of photoelectric sensor. Next is the ultrasonic sensor. Ultrasonic sensor use a transducer to send or receive high-frequency sound signals. This is the example of ultrasonic sensor. Next are the examples of the output devices. One of the examples of output devices is the lamp. Lamps emit light when an electric current passes through them. This is the example of lamps. The next is the motor. Motor is a machine that produces a mechanical movement when supplied by electricity. This is the example of a motor. The next one is the solenoid valves. Solenoid valves is an electromechanical valve for use which liquid or gas controlled by running or stopping an electric current to a solenoid. This is the example of solenoid valves. The next one are the examples of logic devices. One of the examples of logic devices is the relays. Relay is an electrically operated switch. The current flowing through the coil of the relay creates the magnetic field which tracks the lever and changes the switch contact. This is the example of relay. The next one is the timer, a type of relay that delays changing position of its contact when the coil is energized or de-energized. The next one is the counter. Counter is an electromechanical device which stores the number of times a particular signal has occurred. This is the example of a counter. Next topic is the pneumatics. Pneumatics is a branch of science which deals with the study of gases, especially air, its properties and application at pressure higher or lower than atmosphere. Pneuma, the Greek word term, means breath. This is the example of pneumatics. It is also the industrial implementation and application of air-powered actuators and their control devices needed in their operation. The advantages of the pneumatics. One of the advantages of pneumatics is air is available everywhere. Second advantage of pneumatics is compressed air is easily conveyed in pipelines over large distances. The next one is compressed air is insensitive to temperature fluctuations. The next one is the compressed air is storable. Next is the compressed air is explosion and fireproof. Next is the compressed air is clean. Next is compressed air can operate in high working speed. And next and the last is the compressed air is overload safe. Next is the disadvantages of pneumatics. Pneumatic equipment requires good conditioning. The second one is it's only economical up to certain force expenditure of 20,000 Newton to 30,000 Newton. Also, air is compressible. Next is exhaust air is low. Last one is the oil mix air for lubricating purposes, exhaust or escape to the atmosphere. Next is the pneumatic equipment. One of example of pneumatic equipment is single acting cylinder. Single acting cylinder, if compressed air is supplied, air hits piston surface and the piston rod moves out. When air is released, the return spring moves the piston to its initial position. This is the example of single acting cylinder. Next is the double acting cylinder. The force exerted by compressed air moves the piston in double acting cylinder into two directions. This is the example of double acting cylinder. Next is the rodless cylinder. Actuators that use a mechanical or magnetic coupling to impact force, typically to a table or other body that moves along the length of the cylinder body but does not extend beyond it. Next is check valve. Check valve is one-way valve which normally allows fluid to flow through it in only one direction. This is the example of the check valve. Next is the shuttle valve. The shuttle valve is a two-way inlet valve. It allows air to flow on both opposite directions.